It is now possible to build a house in just a few days using fewer materials, less labor, and with virtually zero waste. 3D printing in construction is starting to become a reality. The idea of using giant printers to erect buildings and houses is transforming an industry that has evolved slowly for centuries. Materials like concrete, clay, and even sustainable composites can be molded layer by layer, creating complex, customized, and much more efficient structures. This technology promises to revolutionize the way we build and could also be the solution to challenges such as the housing crisis, reducing environmental impact, and even construction in extreme locations, like deserts or who knows, even other planets. From now on, you'll learn how this technology works, what materials are used, and the challenges and possibilities for the future of construction. To understand the impact of 3D printing in construction, it's important to compare it to traditional building methods, which have dominated the industry for centuries. In conventional methods, the process is usually slow, manual, and labor-intensive. Bricks, cement, steel, and wood are the most commonly used materials, and the work often requires multiple specialized professionals for different stages, such as masonry, finishing, and electrical installation. Additionally, material waste is a significant issue, along with high costs and environmental impact. With 3D printing, however, the process is completely different. The structure is designed using software, and then giant printers apply the material layer by layer, just like a regular printer, but on a massive scale. This eliminates the need for molds, cutting, and often even intermediate steps, reducing material waste by up to 60%. Another advantage is construction time. Projects that would take weeks or even months to complete using traditional methods can be finished in just a few days with 3D printing. And this doesn't compromise quality. On the contrary, the precision of the process results in strong and durable structures. Customization is also a major highlight. In traditional methods, design changes are often time-consuming and expensive. But with 3D printing, it's easy to create unique and innovative shapes, making bold architectural projects much more feasible. This comparison makes it clear that 3D printing isn't just modernizing the industry. It's introducing a whole new way of thinking about construction with a focus on efficiency, sustainability, and innovation. So how does 3D printing in construction actually work? The process is quite similar to the small-scale 3D printing we're familiar with, just on a massive scale and using construction-grade materials. It all starts with a digital model. Architects and engineers design the structure using 3D modeling software, like AutoCAD, Revit, or other specialized programs. This model is then converted into precise instructions that guide the 3D printer. The magic happens during the printing process. Instead of ink or plastic, like in regular 3D printers, construction 3D printers use materials such as specialized concrete, mortar, polymers, or sustainable mixtures. These materials are deposited layer by layer, one on top of the other until the final structure takes shape. The principle is simple. The printer applies the material through a nozzle, controlled by an automated system. Each layer is placed with extreme precision, following the project's design. As the layers build up, the structure takes shape. Walls, beams, and even decorative elements are molded in a single workflow. One of the biggest advantages of this technology is the ability to print complex and customized shapes that would be nearly impossible or extremely expensive to achieve with traditional methods. For example, curves, unconventional angles, and organic designs become easy to produce. Additionally, since material is deposited only where needed, the process generates far less waste. Everything is digitally controlled, ensuring impressive precision and efficiency. Depending on the printer size and the project, it's possible to construct anything from small houses to entire buildings in record time, as much of the work is automated, requiring minimal human intervention. In other words, 3D printing in construction is essentially the act of stacking layers of material, but with near-surgical precision, delivering results that combine speed, sustainability, and innovation. A real-world example of this technology can be found in Dubai, because honestly, where else? When it comes to innovation and futurism, Dubai is always ahead of the curve. The city, famous for its breathtaking skyscrapers and bold projects, is investing heavily in this technology to revolutionize the way buildings are constructed. One of the most iconic projects is the Office of the Future, the world's first 3D printed building. Completed in 2016, it was built using a massive 3D printer standing 20 feet tall and 118 feet long. The entire structure was finished in just 17 days and required only a small team of workers. The building, which houses the administrative center of the Dubai Future Foundation, is proof that 3D printing can be applied not only to affordable housing, but also to sophisticated corporate buildings. It combines modern design, energy efficiency, and sustainable materials, aligning with Dubai's vision of becoming a global innovation hub. Dubai has set an ambitious goal. By 2030, at least 25% of the city's buildings will be constructed using 3D printing. This includes homes, public buildings, and even urban infrastructure. The technology is expected to reduce construction costs by up to 70% and execution time by up to 80%, while also lowering environmental impact. This trend reinforces the idea that 3D printing is not just a futuristic concept, it's a game-changing reality that could transform construction on every level. And as always, Dubai isn't just following this transformation, it's leading the way. Now let's talk about the benefits of this technology. One of the biggest advantages of 3D printing in construction is the speed at which structures can be built, along with the significant cost reduction it offers. Compared to traditional construction methods, which take weeks or months, 3D printing can create houses and buildings in days, or even hours. A project that would typically take months using bricks, cement, and a full crew can be printed layer by layer in less than 24 hours. And all of this happens without compromising the strength or quality of the structure. The process is almost entirely automated. In other words, 3D printers don't require dozens of workers on site. With a single machine controlled by software, construction follows a continuous, uninterrupted pace. And since everything is digitally pre-planned, there are fewer delays and unexpected issues along the way. Beyond speed, another major benefit is cost reduction. 3D printing uses only the exact amount of material needed for each layer of construction. There's no waste from excess cement, wood cutting, or manual adjustments. Studies show that this technology can cut material costs by up to 30%, in addition to saving on labor, which is significantly lower compared to traditional methods. Moreover, the use of recyclable and alternative materials, such as industrial waste or plastics, further reduces costs and makes the process even more sustainable. These two advantages, speed and cost savings, have a direct impact on the industry with more affordable housing, especially in regions where housing is a major issue, rapid response in emergencies, such as natural disasters, greater feasibility for futuristic and innovative projects, which were previously limited by time and budget constraints. Other key benefits of 3D printing are sustainability and customization. Starting with sustainability, traditional construction is one of the biggest sources of material waste in the world and has a significant carbon footprint. 3D printing completely changes this scenario. The process is extremely precise. Material is deposited only where needed, layer by layer, with no excess or waste. This can reduce material consumption by up to 60%. Additionally, the technology enables the use of alternative and recycled materials, such as industrial waste, repurposed plastics, and even sustainable composites. In other words, it's now possible to build a house using materials that would otherwise end up in landfills. Another crucial factor is reducing transportation impact. With 3D printing, production can happen on-site, near the construction area, eliminating the need for long-distance transport of heavy materials, which further reduces carbon emissions. Now, when it comes to customization, 3D printing opens the door to unique and personalized designs. Unlike traditional methods, where standardization is the rule to cut costs, here flexibility is total. With a digital model, houses and buildings can be tailored to meet the specific needs of each project. Want a house with curved walls or with enhanced thermal insulation? With 3D printing, that's possible without significantly increasing costs or construction time. This technology also enables customized solutions for specific regions, such as earthquake-prone areas or extreme climates. The combination of sustainability and customization makes 3D printing one of the most promising solutions for modern challenges. Less environmental impact in construction, more efficient use of materials, unique, tailor-made projects designed to meet the needs of individuals, communities, and even entire regions. You might be wondering why this technology isn't more common yet. Despite all the innovation and recent advancements, 3D printing in construction still hasn't become widespread in the market. This is because there are still some barriers that need to be overcome. First, there's the cost of the machines. Large-scale 3D printers are extremely expensive. It's not just the price of the machine itself, but also the costs of maintenance, transportation, and operation. Smaller companies still can't afford to invest in this technology, which limits its large-scale use. Another issue is the lack of regulation. Since 3D printing in construction is a relatively new technology, many countries still don't have technical standards and building codes to validate these structures. This raises questions about safety, durability, and structural resistance, making project approvals and market trust more difficult.